All dear students, in this video we will be discussing about Karl Pearson's coefficient of correlation. Karl Pearson's coefficient of correlation is an extensively used mathematical method in which the numerical representation is applied to measure the level of relation between linearly related variables. And here the coefficient of correlation is expressed by a small r. So the formula for Karl Pearson's correlation coefficient is somewhat like this. Small r, that is Karl Pearson's coefficient, is equals to summation of small xy divided by square root of summation of x square into summation of y square. Okay, so in this formula you can see we have got small x and small y. Fine. Here small x is equals to capital X minus capital X bar, whereas small y is equals to capital Y minus capital Y bar. Okay, so you will get to know all these things with the help of any example, the problem that will solve. Okay, now over here whenever a correlation of coefficient is 1, that is plus 1, that means every increase in one variable there is a positive increase in the other fixed proportion. Okay, so when one variable increases, the another variable also increases. Okay, or if one variable decreases, the another one also decreases. Like for example, shoe sizes changes according to the length of the feet and are perfect almost correlation. Okay, so as the size of your foot increases, the shoe size also increases, so that is a positive correlation. Next, when a correlation coefficient is -1, that means every positive increase in one variable there is a negative decrease in the other fixed proportion. For example, the decrease in the quantity of gas in a gas tank shows a perfect, almost inverse correlation with the speed. Isn't it? When you are increasing the speed of the flame of the gas will start decreasing. The level of the gas will start decreasing in the gas tank. Okay, so more is the speed, lesser will be the amount of gas in the gas tank. So that is a negative correlation. And similarly, when a correlation coefficient is 0 for every increase, that means there is no positive or negative increase and the two variables are not related to one another. Okay, so coefficient might be +1, -1 or 0. Okay, so we'll have an example over here. Compute Karl Pearson's coefficient correlation from the following data. Okay, so you have got price and supply unit, that might be electricity unit. So over here our price will be capital X and the supply unit will be a capital Y. Okay, and this is the formula that we need to use, that is Karl Pearson coefficient designated by small r is equals to summation of xy divided by square root of summation of x square into summation of y square, and that is small x and small y, and with the help of the following formula we can identify the value of small x and small y. Now over here we have got small x and small y, isn't it? So with the help of capital X, the quantity that we have, and the capital Y also, that is the supply, that also reading we have over here, we can calculate x bar and y bar, and by which we can calculate small x and small y. Now first of all we need to make a table over here and we need to write the quantity, the values, the variables of x and y, which is as follow. Okay, now just see in the formula over here we need to identify small x, which is capital X minus x bar is equals to small x. Similarly small y, how to calculate it? Capital Y minus y bar is equals to small y. Okay, now as you can see in this formula we have got the value of capital X, but we need to calculate x bar. So the formula for calculation of x bar is as follows. X bar is equals to summation of x divided by n. Summation of x means all these x value we have, no, all this x value we need to add up all those things, divided by n. N is the number of observations. So x bar means 10 plus 20 plus 30 plus 40 plus 50 plus 60 plus 70 divided by 7. 7 is the number of observation. So you add up all these things, 280 divided by 7, which is equals to 40. So the value of x bar is 40. Now by this we have got the value of x bar, isn't it? So this value of x we have already, and x bar value we have calculated over here. Now we can easily calculate the value of small x. So 10 minus 40 is equals to minus 30, 20 minus 40 is equals to minus 20, 30 minus 40 is equals to minus 10, 40 minus 40 is equals to 0, 50 minus 40 is equals to 10, 60 minus 40 is equals to 20, 70 minus 40 is equals to 30. Okay. Now again you look up this formula. Okay, in this box, the formula box, you check out. We want summation of x square, means we need to take square of these all small x value and then we need to sum up of this. So the another column in this table is for x square. So minus 30 square is 900, minus 20 square 400, minus 10 square 100, 0 square is 0, 10 square is again 100, 20 square 400, 30 square is 900. Okay, so we have got the value of x square and we need to produce summation of x square. So you need to sum up all these things. We got 2800. Fine. So this thing is completed. Next again you check out this formula box. We need to calculate y. So we have got the value of capital Y. We need to calculate y bar first and then we can calculate easily the small y. So for y bar we have got same formula. Y bar is equals to summation of y divided by n. So you need to sum up all these y values. Okay, all these y value we need to sum up. 8 plus 6 plus 14 plus 16 plus 10 plus 20 plus 24 divided by 7. 7 is n, that is number of observations. So add up all these things, we will get 98 divided by 7, which is 14. Okay, so y bar is 14 and capital Y value we have got already. So you can calculate small y. 8 minus 14 is equals to minus 6. 6 minus 14 is equals to minus 8. 14 minus 14 is 0. 16 minus 14 is 2. 10 minus 14 is minus 4. 20 minus 14 is 6. And 24 minus 14 is 10. Okay. Now again you check out this formula box. We want summation of y square. Okay, so first of all you need to calculate y square and then we need to sum up all those things. So in the table another column is for y square. Minus 6 square is 36, minus 8 square is 64, 0 square is 0, 2 square is 4, 4 square 16, 6 square 36, 10 square 100. Now you need to produce summation of y square. You need to add all these y square value, you will get 256. Okay, so this is y square also we got. Next again you check out this formula box. You want summation of xy, means you need to multiply x with y and then you need to sum up all those things, to which we will get summation of xy. Okay, so xy you need to calculate to so that won't be any kind of confusion. I have added all those things, just you can see value of x and value of y. So minus 30 into minus 6 is 180, minus 20 multiplied by minus 8 is 160, minus 10 multiplied by 0 is 0, 0 multiplied by 2 is also 0, 10 multiplied by minus 4 is minus 40, 20 multiplied by 6 is 120, 30 multiplied by 10 is 300. Next you need to calculate summation of xy, and this thing you need to do very much carefully because minus negative value is also there. So 180 plus 160 minus 40 plus 120 plus 300. So you will get summation of xy, which is 720. So now you have got all these things. Summation of x square we have, summation of y square we have, summation of xy also we have. Okay, so separately I will be writing over here summation of x square, summation of y square, summation of xy. everything we have. Just you need to add all these values into the formula, that is r equals to summation of xy divided by square root of summation of x square multiplied by summation of y square. Okay, you add all these things. 720 divided by square root of 2800 multiplied by 256. Go on calculating it, you got the value 0.85. So Karl Pearson coefficient is plus 0.85. Okay, so this is how you will be calculating the Karl Pearson coefficient of correlation. This was all about today's video. I hope you people found this video helpful. Thank you for watching.